Okay, so let's get into this. We've all been there, right? You're running an HDMI cable, just trying to get it across a room.
Mm-hmm.
And suddenly, the screen flickers, or it just goes black. That classic copper cable limit.
It's so frustrating. But the tech we're looking at today, it basically laughs at this limits.
It really does. So we're doing a deep dive on the Kramer 692.
Right. And technically, it's a high-performance HDBaseT 2.0 fiber receiver.
Hmm.
And that word, fiber, that's the whole story.
That's the key.
It turns all those signals into light, so it just bypasses the problem of electrical resistance entirely.
And the mission for us today is to figure out if these specs are for real, because they look absolutely wild. We're not talking about extending a signal across an office.
No, not at all.
The claim here is that this little box can push a 4K video signal up to 33 kilometers.
That is, yeah, 20.5 miles.
20 miles.
It's a huge number. But, we have to be a little precise here. That headline number, the 33 kilometers, that's specifically for single-mode fiber. If you're using multi-mode fiber, which is maybe more common inside a big building, you're looking at more like 3 kilometers, about 1.8 miles.
Which, that's still massive compared to a 50-foot HDMI cable. But the difference between 1.8 miles and over 20 miles, that's enormous. How does it do that?
Well, it's actually modular. The unit has these ports for what are called pluggable OSP, SFP plus units.
Okay.
Think of them like little interchangeable cartridges. You just plug in the module that matches the type of fiber you're using. That's how they get that ultra reach. You're swapping the light engine itself.
So it's adaptable. But when you push a signal that far, 20 miles, you just expect it to look terrible, like a bad internet stream.
You really do. But the specs say it holds up to 4K at 60 hertz with 4.2.0 color sampling.
And for anyone listening, 4.2.0 is basically just a smart way to compress the color data without really hurting the image quality you can see.
Exactly. So the takeaway is the image isn't going to look all muddy just because the source computer is like in a different town.
Okay, but there's this one feature that I think is the real headache saver. IED Pro. It sounds like jargon, but what does it actually do?
It's so important. ED is, think of it like the digital handshake between your screen and your computer.
Okay.
The screen says, hey, I'm a 4K display. The computer said, okay, here's a 4K signal.
Mm-hmm.
But when you stick 20 miles of stuff in between, that handshake can just fail.
And then your computer defaults to some horrible low resolution.
Precisely. This IED Pro thing, it makes sure that handshake happens smoothly, so it's truly plug and play. You don't have to fiddle with settings on a machine that's miles away.
That brings us to the whole Swiss Army knife part of this, because
right.
It's not just for video, is it?
Not at all. Because it's HDBaseT 2.0, it's carrying this whole data stack along with the video. You get Ethernet, RS-232 control, and USB.
And the USB part is interesting. It lets you do a KVM setup, right? Keyboard and mouse?
Exactly. So your powerful, loud, hot computer can be in a server room across the city, and all the user has on their desk is this receiver, a monitor, and a keyboard.
But I did see a pretty specific warning in the manual about that USB port. It flags something called isochronosis devices.
Yes, that is a critical catch. Isochronous is a type of USB transfer for devices that need a guaranteed, steady data stream. Think like a high-def webcam or a USB microphone.
So you're saying don't try to run your Zoom calls through this thing?
I would strongly recommend against it. The documentation says delivery isn't guaranteed. It's for control clicks and keystrokes, not for heavy streaming peripherals.
Got it. And on the audio side, there's this audio embedding feature.
Oh, this is very clever. It's for live situations. So imagine a lecturer is showing a video clip that's coming from that remote server, but they want to talk over it. This lets them plug a local microphone right into the receiver at the podium, and it will inject their voice into the audio stream, replacing the original track.
That is smart. It saves you from needing a whole separate mixer. So let's talk practicals. An IT manager sees the price tag, around $2,300.
It's not consumer gear now.
Right. And they're asking about maintenance. Do I have to send someone on a 20-mile drive every time it glitches?
They've thought of that. It has a built-in web UI. It connects to the Kramer network. You can manage it and check the signal health remotely.
And the box itself, it's fanless, so it's silent. And it's a half-width rack unit.
Yeah, so you can fit two of them side by side in a single rack space. It's built as infrastructure, which is what that price reflects. It's for mission-critical stuff.
So really, the big takeaway here is that this technology just completely redefines what local even means for a computer setup.
It does. It basically removes distance as a design constraint for high-quality AV. You can centralize absolutely everything.
It's pretty wild. Which leads me to a final thought for you to chew on. If we can now effortlessly extend a full, uncompressed workspace 20 miles away, does this signal the end of the office PC tower? Could we see a future where entire business districts run off a single centralized computing hub and our desks are just these little receiver boxes? Something to think about. Thanks for listening to this deep dive.